Ready? So, last week, who's excited? I know I am. So, did everybody see the announcement? Yeah? Okay. For those of you who may not have seen the announcement, the department is now lending me some additional resources in the form of one of the IT guys who's going to assist in debugging the auto grader and definitely not doing anything that is TA work that nobody's allowed to do because the strike is going on. So that's how that's going. Hopefully things start moving, although the TA also failed to commit the test cases that he was using prior to leaving on the strike, and I haven't been able to get hold of it yet, so I may just have to redo the test cases. But you know, that might not be such a bad thing in the end. It's just going to take time, that's all. So, so anyway, the gigantic shitstorm continues to spiral out of control. So anyway, might as well plug away at C++, huh? So, so modularization. We were talking about like why object-oriented even, right? So in this section we are going to look at C++, a C++ class implementing a gradebook for use in an academic setting. We are going to look at how an organization might go about producing such a software product. When putting together a software project, there are many people that can be involved, but we are going to focus on the following three: the back-end developer, the front-end developer, and the client or end user. In many ways, the end user is the most important person in the deployment of a piece of software. The end user is the customer of the product that is the software. If the end user is not satisfied with the product, they may seek products by other vendors, which means that your company loses money. And it is your job to make your company money, not lose your company money as an employee. So, let's talk about the front-end developer, since we had talked about the end user last time. So, the front-end developer is responsible for creating the end user's experience of the software. It doesn't matter how good the code is underneath. If the user experience is terrible, users won't use it. In larger companies, a front-end developer may be tasked with implementing the designs of a larger design team. So sometimes you have, like, you know, artists and consultants and a bunch of, you know, touchy-feely arts majors who are telling you how to run the UI, and then you as the developer have to just kind of do it, and you know, try to please them, but at the same time fix the mistakes that you know they're making, you know, while sneakily doing so it doesn't look like you're fixing their mistakes, you know. But anyway. So the front-end developer's job is often the management of large amounts of minute details that affect the user's experience. The front-end developer must keep in mind the level of experience and expertise of the program's clients. It's very, very different making Putt-Putt Goes to the Circus versus making, you know, something complicated like MATLAB. That's a good example. MATLAB and Putt-Putt Goes to the Circus are made for two different groups of people, and thus the user interface must be different. Man, you guys even have any idea what I'm talking about? No?
I thought you just made that up.
No, oh no. Ha! Okay. No, it's like back in the 90s they had like, you know how like back in the 90s point and click adventure games were like very, very popular? They had like kids versions. Yes, it's real. There he is. Yeah. What, you think I lie to you? That all I do is lie to you,
No,
huh?
you don't lie to us, but...
Yeah, no, this is a good example of what it looks like, right? So yeah, it was just like a little car, and he did adventure game stuff, and like, I don't know, it was kind of funny, but primarily for the amusement of like 6-year-olds, you know? I don't know, like, when I was a child, when I was like in the age range for this type of software was after my time, actually, if you believe it. For me, when I was like 6, the idea that a computer could do like color display was like very cool. Most computers were just like, you know, green or yellow, you know, like monochrome monitors. But yeah, anyway. So anyway, don't underestimate the amount of work that the front-end developer does. In a lot of ways, they are at least equally important with the back-end developer. All right? The back-end developer is responsible for the functionality of the program, responsible for designing, implementing, testing, and debugging the guts of the program. Decisions about the functionality to be implemented are ideally client-driven, not back-end developer-driven. In large companies, there are employees who are dedicated to testing and quality assurance. It doesn't matter how pretty the interface is if the software doesn't work. See the new Pokemon games. So the back-end developer will generally be the better mathematician because they have to implement all kinds of advanced data structures and you know, they have to be able to know how to optimize, right? And know which data structures to deploy for which purposes, when to use a hash table, you know, when to use a graph representation, all of this type of stuff, when to use a B tree. That's what they need to know, right? So because they have, you know, the more highfalutin math and the fancier degrees, they think they're better than everybody else. But, you know, again, it doesn't matter how good the back end is if the UI sucks, and it doesn't matter how good the UI is if the back end sucks. So both need each other. It's a symbiotic relationship, just like on the Magic School Bus. So here's an overview of what the various people would be responsible for in gradebook software development. So, up to and including the files they're working on. So, let's start, as all things should, with the end user. So, the end user should only need to worry about the end gradebook executable application. They should not have to worry about compilation or linking or any of the processes required to produce the executable, because they are not intended to be a programmer. We then have the client code programmer, who is our front-end developer. The client code programmer develops the main function, or client source code, right? Also using definitions included in gradebook.h. Gradebook.h, you can see, as well as the C++ standard library, of course. Gradebook.h is the only piece of, the only file inside of the intersection of this Venn diagram, right? It is the only piece of code that both the front end and the back end developer have to worry about and work on, hopefully come to an agreement about. This gradebook.h is a contract between the between the front end and the back end developer, right? And this is like not contract in the sort of the legal or the social sense, but more like contract in like the Hobbesian sense, where it's a promise between two people. The back-end developer agrees, these are the functions that I will support. You may use them as you please. If you put this in, you'll get this out, absolutely fine. The front-end developer says, I need these functions to exist. I want to be able to put these in and these items in and get these items out, right? So somewhere between the front end and the back end developers' ideas of what the library interface should consist of, there will be some kind of middle ground. There will be some kind of compromise, right? That is what header files are for. The back-end developer, of course, will be working on gradebook.cpp, which is the implementation file. It contains all of the definitions for all of the interface that's been declared in the H file. Both of these people can compile their works separately, but all of them are linked together at the end by the linker before being passed down as an executable application to the end user, right? So that is why in C/C++ programs, individual compilation of individual C files with linking at the end is the way that C development, C++ development is generally done. It allows the separation of concerns into individual files. This perhaps was less of a concern, this was more of a concern back in the day when, back before the existence and widespread use of repository software to manage changes and merges and branches and all of that lovely stuff that now enables modern software development. You have to understand the C++ ecosystem as having developed back in the 1970s before any of that was a thing. And these files were being passed around on floppy disks, right? So that's why it's like that. It is still a good organization, though. Just like a lot of old video games are still good video games. It's still a good way of thinking about software projects. Excellent. Any questions so far? Yeah.
Would it be difficult for the front-end programmer to test things if they really don't have any of the functions that they're going to use?
Yeah, to an extent, back-end development must precede front-end development at least a bit. If you're working on if you, for example, were working on a personal project, a personal coding project, and it was just you, what do? The front end or the back end stuff first?
Back end.
Right, because without the back end, there's nothing to send to the front end, right? What will probably happen, actually, though, you'll do a certain amount of back end development, get a certain core functionality working. Then you're going to have to do some UI design to make sure that it works. When I'm talking about this kind of stuff, I'm thinking about projects I've done, which have mainly been like video games and stuff, right? Some of you may have noticed there's a trailer for a puzzle game on my YouTube channel. It's called Hexy Hashy. It's not a fantastic game, but it's serviceable. So that game is it's like you have a field of nodes, and you have to draw either single or double bridges between the nodes, and the number of bridges each node accepts is written on the node. So it's like 2, 3, 5, 3, 3. And then like the puzzle is presented to you as just the nodes, and you have to figure out how many bridges go where. Like that's the puzzle. So it's like, in terms of algorithms, it's a graph algorithm, but it's done on like a hex grid, hexy, hashy. It's based on a puzzle developed by the same people who developed Sudoku. The puzzle's called Hashi-Wakakero, I believe. And anyway, so it's a graph algorithm. So I need a lot of functions in the back end, like test to see if 2 nodes are connected, you know? Add edge between 2 nodes. I need a representation, like a data structure in the back end that represents this, you know, this data structure, you know? All of that stuff has to precede being able to see anything, right? But once I've got a certain amount of that done, then I can start doing rendering stuff and do like a simple little render because doing the rendering will help you debug this guy, right? So, you know, they both kind of grow in tandem, but yeah. Anyway, that's probably more answer than you wanted for that question, but all right. So, in object-oriented programming, the interface between the front end and the back end software is encapsulated by class interfaces. When you use an API, this is what you're doing. The word API is thrown out around a lot these days. Basically what it means is, what are the publicly accessible members of the class? That is the API. Ideally, the design of the interface is the product of negotiation between the front and back end developers. In the previous example, the interface is set out separately in gradebook.h. The back end programmer works on gradebook.cpp, which implements the agreed upon interface contained in the header file. The front end programmer's work is encapsulated in the main and related functions. Having separate people work on separate files is a good way to avoid race conditions. You guys know what a race condition is? Okay, this is, you might not hear about it again until 4th year, but basically, okay. So let's say that you have a file, right? You have a file, and you have 2 people who are interested in making modifications to the file, right? Let's say both of these people open the file at the same time, right? They both are making modifications to this open file. Whose work gets saved? Assuming they're not aware someone else is working on the file. Only one person's work will get saved. Who is it? Yes?
Whoever finishes first.
Actually incorrect, but whoever finishes last.
Oh, really?
Yeah, so if, let's say, you know, person 1, person 2, let's say that person 1 gets finished, writes their stuff back into the file. The copy that person 2 is working with was generated from the earlier version, right? So they make their modification, maybe put a star in the document or something. When they write their document back, person 1's will be overwritten completely, and the version that will be kept is the version they came up with, right? So, because it's an overwrite system, right? So, that is what is meant by race condition. It's like racing for the finish line, not certain other meanings of the term. So it's because two people are like, basically the result that's in that file is dependent on the order in which people, perform safe operations or something like that, right? Make sense? So how do operating systems solve this problem? By locking you out of the file. So what happens, what happens to prevent race conditions on files, right? Individual files in an operating system. It's assumed that two people will not request access to the file at the precise same moment, and even if they did, CPUs can only execute one thing at a time anyways, but multi-cores, but whatever, It's the probability that these two ask for the same thing at precisely the same clock cycle is infinitesimal, right? So, person one requests the file. They put a big protective bubble around that file until they're done with it. Any incoming requests will bounce off of the bubble until such time as user one releases the thing back to the file system. This is called a mutex, which stands for mutual exclusion. Yes?
Is that kind of what happens when we work on shared documents on Word or something, where someone's cursor is locked and you can't type?
Yes, exactly. So yeah, so that's how Windows decided to solve the problem for shared documents for Word. Is that it?
Yeah.
Yeah, that just one person gets the cursor at a time.
In a sense,
certain
on a certain line.
Certain chunks of text.
Okay, so they chunk it out, but within your chunk.
Instead of those irritating thing.
Yeah.
Yeah, because
If you see a missing period and you just want to add a period, it's like no, you can't.
Yeah.
Then it freezes and it doesn't work, even if they've moved off of it. And you're like, are you sure you moved off of it? And they're like, yeah, I have. I don't believe you. Yeah, exactly. And then it's like there's too many conflicts. Yeah.
Windows sucks. I think we've established this at this point. The memory load of the Office suite is absolutely astronomical for what it does. The operating system's terribly written. Office itself is like a huge vector for ransomware attacks, by the way. And not to mention, now you're telling me they can't even manage, so this is an alternative, right, to using mutexes. You keep a change log, right? So the way that somebody who's a slightly more intelligent than Microsoft, say for example Google, the way that Google will solve the same problem, right? You have the file, right? You have the users, and then you have a wibbly-wobbly interference middleware layer, all right? The users are sending commands into the middleware. The middleware is the only thing that's, the middleware itself is changing the file, right? So basically, whenever you insert the word foo, let's say this guy wants to insert foo, right? This person wants to insert bar, right? On line 1, line 3, right? These get turned into commands, right? I foo at 1 or something like that, right? These get put into a big queue, right? You can imagine a big queue of these instructions. and then it just executes the instructions one by one, modifying this guy as it goes, right? And then it, it's also responsible for like maintaining a view for the users, right? So that they can, this is why it takes a little, like, you'll notice that like Google, it's probably gotten better since last I used it, but you'll notice something like Google Sheets has like a slight delay between typing and the words showing up, it's because it's having to go through a middleware layer. But that's a different approach to the same problem, which works better. However, it does require more skill. But anyway, so so why bother separating the class header and implementation files? Incidentally, this approach is like the new fangled approach that's being used recently in the internet age. The Mutex solution was like the one that you would have like in the pre-internet era or the proto-internet era. So, so why bother separating the class header and the implementation files? Let's imagine the following scenario. Jack and Jill are working on a C++ project together. Jack is the back-end programmer and Jill is the front-end programmer. Jack decides not to separate the implementation into a different file due mainly to laziness. Jill needs to look at the header file in order to write the front end. When she looks at the library Jack has worked on, she is able to read all the implementation details of the class. When Jack wrote his code, he left in a keyboard shortcut for testing purposes. Jill sees this shortcut and uses it in her own code. Later, Jack removes the shortcut because he only intended it to be temporary, but of course he never left a comment to that effect in his source code. Jill performs the final compilation but misses the bug because she believes she has already tested that aspect of the code. The software is then shipped to the client with a major bug. He's so upset with the situation that he not only takes his business elsewhere, but he leaves a nasty review on the app's store page. The review was so nasty that it sends both Jack and Jill into a deep spiraling depression from which they only emerge 6 years later. By that time, their software company has failed, and since they were entrepreneurs, they have to liquidate all their personal assets to cover the company's debts. Don't let this happen to you. So, like, joking aside, though, right? This type of thing, where like you put a temporary shortcut in, like that is totally 100% the sort of thing you do. Like not to talk about my video games again for the second time in class, but I have a pinball game as well on Steam. It's called Super Steampunk Pinball 2D, and it has a bonus round, which of course takes a lot of effort to get to, or at least takes some effort to get to because it's a bonus round. So what do I do in order to test the bonus round? I put a cheat P. Yeah, I press B to get to the bonus round. You know. Did I ship the game with that left in? No. But you know, some people maybe wish I had. But actually, there were some people who actually liked the pinball game. But yeah. Anyway, so you can imagine if you had like someone who is looking at stuff that they shouldn't be looking at, looking specifically for ways to make things easier for themselves, taking advantage of that sort of thing is precisely the sort of thing they would do, right? So anyway, so there's your little scenario. Any questions? Cool. Jack could have prevented this situation by separating his class's interface from its implementation. The shortcut Jack added would have been included in the implementation file only, since it was never part of the intended interface. Then when Jill went looking for the information she needed to call Jack's member functions, she would not have seen the shortcut. So there we go. Classes can also contain function prototypes. just so you know, this is what a header file looks like in C++. You can see that we still include class definitions inside of the header file, because that information is necessary. You can see what's private and what's public, and of course Jill will know that only the things that are public are the things she has to worry about, right? So, you got anybody read the Hitchhiker's Guide to the Galaxy books? Yeah. You know the "not my problem" field, which is a concept in some of the later books. It's like you can sort of erect a kind of a force field around certain things in the books called the "not my problem" field, which impresses on people's brain that whatever's inside the force field isn't their problem, so they just completely ignore it. This is how spaceships travel to and from Earth and things. It's like people see the spaceship, but it's not their problem, so they don't worry about it, right? But yeah, anyway. So that's what this looks like in C++. Do we have class? Thursday's the last day of classes, right?
Yes.
So we have 3 classes this week. Yeah, okay. So in many ways, so let's talk about exception handling now. And in many ways, exception handling in C++ is similar to that in Python. Python's try and except blocks are try and catch blocks in C++, so you have to change exception to catch. Python's raise becomes throw. Did they do exception handling with you at all? A little bit? Yeah? I'm getting nods and people shaking their heads. Yeah. Well, the example that I'm about to give should be sufficient for you to understand the concept. That's not actually terribly difficult. So, in Python, in general, the semantics behind these constructs are consistent between the 2 languages. However, there are some notable differences. In Python, the thing you raise is a class inheriting from exception. So in Python, when you get like a value error, what has been produced is an object of the value error class that sort of, it's like all of your precious functions are fragile layers of glass, and then the exception is a big bowling ball that will smash through every layer of function that you have until a catcher's mitt is there, and this is what the catcher's mitt is a try except. So an exception will close out functions until it hits a try except somewhere inside of the call hierarchy, or the call stack. So, yes. So you create an exception by either raising it in Python or throwing it in C++, which extends the ball metaphor. So, in C++, you can throw anything, integers, characters, strings, objects, whatever you like. So you can throw error codes, for example. The catch blocks in C++ do not match the type of the exception raised, but the data type of the thrown value. So rather than having exceptions be their own specific little class that gets dealt with in its own specific way, you can throw anything in C++, and you can catch anything in C++ so long as you know the data type of the thing you're trying to catch. Make sense? Cool. So, here's an example. Factorial, right? Just regular factorial calculation using a for loop down here. So, if n is less than 0, throw n, right? So, we all know that the factorial is not defined for negative numbers, right? So if the factorial function receives a negative number, it basically says, I don't want this, and it throws it back. And the thing it's throwing back is the negative number that was the failed input, right? Which, if you think about it, could actually be a lot more useful than the way Python does things, just saying. So, We also have this special case that if the number that we're trying to calculate the factorial of is 1337, we throw a leet exception. This is, of course, we're throwing a string literal here, which, gets handled as a string. In order to catch that, you have to catch a string, which is fine. And if neither of these cases execute, then we just calculate the factorial as necessary. Make sense? Question?
So what's the difference between throw and return? Like, where's
Oh.
throw sending it?
Well, I have to do the second part, which is the catch. Yes?
What was the reason for like the leet error? Like why 1337 is arbitrary?
Oh, because in leet speak, 1337 is leet. It's a joke.
Oh.
Yeah. Yeah, 1 is L, 3s are E's, and T's are 7s in leet speak. So it's gamer talk. So let's consider now our the way that we now catch these errors, right? So in main, we have I, which is 1337, coincidentally, and we have J, which is 0. We have the try block. So the way that a try block works, we put a series of statements inside of a try block. If an exception is thrown while these statements are executing, we immediately terminate execution inside this block and jump to the correct catch statement. So catch int, right? Error, that outputs error factorial called with bad input, and then it gives us the input. Catch with ellipses catches the rest. See out unknown error. Make sense? Any questions? Yes.
Where does the n come in that was thrown?
Where does the which?
The n.
The n. Oh,
You threw n, right? In
Right.
the first one?
so let's say that, just for the sake of argument, I is negative, right? Negative 10. We call factorial with negative 10. So n's value here will be negative 10. If n is less than 0, so we enter this if statement, throws the value of n, which is negative 10, right? That terminates this function, right? Because so this is the difference between a throw and a return. A throw is kind of like an all functions return, right? So if this were a recursive implementation of factorial, right? An exception occurring at any time in the recursive calls will smash through all of the recursive calls all the way through until it hits a try catch, unless it doesn't hit a try catch, in which case it will crash your program. Does that make sense? Whereas a return just returns things nicely to the previously called function.
Yeah.
So it's like a return statement, but its power is over 9,000. Not to use even more outdated memes, but you guys should expect that by now. So yeah. So when we have the negative 10, which is returned, we have a series of catch statements in the same way that function overloading resolves based on the data types of the input to the function. Catch overloading resolves by the same mechanism. So because we have returned an integer, we're going to use the catch for integers, which, Q will receive negative 10. So when we say C out, error factorial called with bad input, negative 10, and line. Make sense? Any other questions? Good. So, calling with I set to 10, the factorial of 10 is this big bastard. Calling I set to -2, error, factorial called with bad input, -2. Calling I set to 1337, unknown error. So notice that in this case, we actually have more information available about this exception than is being printed. So this is a poorly designed piece of software because it is, the better thing to do would to be write a catch case that takes strings and then output the error string if it's received, right? That would be better than just saying, oh, I don't know what the error is. Yes?
Can you specify throws to certain catch? Like, for example, you had more than one throw of an integer, and you wanted different, error statements to be printed. Could you specify which one it's caught by?
The way that you would do that is not with multiple catch statements, it's with an if statement inside of the catch. Right? So if you wanted, if you're catching an integer, right? And let's just say for the sake of argument that this, rather than, passing back or throwing this string, was throwing the number as well, right? You could take Q, test it to see whether it's negative or 1337 inside of the catch block, and then output different things based on that. Make sense?
Yep.
But as far as I'm aware, there's no way to gate these with Boolean conditions or anything. Yeah, good question though. Any other questions? Okie dokie. So, the catch case matching the catch case matching that occurs is very similar to overload resolution, as previously mentioned. The list of catch cases is examined, and the catch case which matches the thrown data type is used. If you want a catch-all case, it is written case with ellipses. Notice that the string, I actually sometimes I second guess myself with these slides, and I was like, is it really ellipses? But yeah, it's really ellipses. Does that seem like I would do the same thing to leave code out of an on-slide example? But that's actual syntax. Notice that the string returned by the second throw statement in factorial is not an error message that will be printed in this case. If you want this functionality, you have to implement it yourself. This manner of exception handling has created the culture of error codes. So, exception -374 will, that'll have a particular meaning. In these old programs always used to come with a big fat manual. Now we just have wiki pages. But they used to come with these great big, spiral bound manuals where you could have table upon table upon table of error numbers and what the error meant, and you'd have to, if you got an error code, you had to look it up manually to see what the error code meant for that particular program, and all kinds of stuff, and it was wrong half the time anyways. That's how things used to be. Now things are, things have been improved considerably by the existence of search engines and Stack Overflow. But all of those people who answer all of your questions about what error messages you're dealing with on Stack Overflow probably at some point either have the experience or one of those big, spiral-bound error code books. So, yes. Anyway, comics. Yes, let's go. Next one. Topic 11. Continuing on with object-oriented programming. Cool. Any questions about the previous? Okay. So we're going to dive a little bit more into object-oriented. We're going to talk about inheritance, polymorphism, composition, also miscellaneous small topics, etc., etc. So, in this lecture, we're going to be talking about some advanced topics in class organization, particularly composition, inheritance, and polymorphism. We'll start with composition because it's the easiest conceptually, but we'll get to the rest of them in time. So, composition is when classes have objects of other classes as members. So, imagine for a moment you have a class for points in three-dimensional Euclidean space. All right? Now let's imagine that you have a class for a triangle. What is a triangle made of? All right?
3 points.
3 points. Three-dimensional. So three-dimensional points will give you a triangle in three-dimensional space, right? So what might we, what's an application for a collection of triangles in three-dimensional space? In computing. Everybody knows this, you just don't know you know it. Yes?
3D video games?
Wireframe models, yes. So that's how so if you have wireframe model as a class, right, that is composed of some number, some non-fixed number of triangles in space, right? Triangles themselves are composed of 3 points, which is a fixed number of points because otherwise it would be a polyhedron. Make sense? Triangles are used because they're very simple, and it's like ray intersection with a triangle is the easiest of all these all ray tracing calculations, unless you do like spheres. Spheres are also reasonably easy, but yeah. Cool. Yeah. So I guess we're done. Thank you very much, folks.